This is the size of a computer today, as powerful as the biggest of only a few years ago, but 1,000 times cheaper. What makes it possible is this. Inside here is a silicon chip with all the important components of the computer etched onto its tiny surface. It's called a microprocessor. Electronics pervades almost all products and manufacturing techniques, and when key components become 1,000 times cheaper through the use of silicon chips, there'll be dramatic effects. The biggest changes are yet to come, but some we've seen already. The manufacturers looked for a way to sell their chips directly to the public, and at least 20 manufacturers rushed in to make calculators. A new industry was born, selling £100 million worth of chips a year. The existing mechanical calculator industry came to an end. They couldn't cut their prices, and they didn't know what had hit them. They were out of business. But the competition between the electronic calculator manufacturers was fierce. So fierce that after 4 years there are only 2 or 3 chip manufacturers still making calculators. Their next idea was to sell chips in watches. The price of the cheapest watches came down and down till now it's below £10. The effect on the Swiss watch industry was shattering. They laughed when the cheap electronic watch was introduced, calling it a passing fad. At that time, they used to make half the watch movements in the world. But the electronic watch has stopped all that. 17 firms went out of business, and there was widespread unemployment. Europe lost a £200 million industry to the Americans.
I didn't get that. Show the catch before you get back. Oh, quick, get long 3,000.
Now there is a new war. This is the current way chips are sold directly to us. It may seem trivial, but making games around chips that control TV screens is an industry worth £250 million a year, and it's growing.
Come on, this one. I have this. Got it.
The imaginary rockets are controlled by the same chips the US Army used in their defense programs. Made on the same production lines their demand created. But the significance of the chip does not lie in gadgets. Her whole future will be changed by cheap electronics. The way she will live, the kind of work she'll do, will be different. You can already see the change happening. The future is there if you care to look. The new supermarket checkout terminals have microprocessors inside them. They're now called point-of-sale terminals. Each one is a computer in its own right, and they have the power to do a whole lot of new things the mechanical cash registers couldn't do. Besides totaling the bill, this terminal can check up on the validity of a credit card. All the cashier has to do is punch in the card number, and the terminal makes its own automatic telephone call. Microprocessors applied to selling petrol have already led to 100,000 petrol pump attendants being rendered unnecessary. The change can already be seen in the office. There's a new machine coming into use. It's called a word processor, and it's probably a more important step than the invention of the typewriter. It uses no paper. The text can be moved around, edited, and instantly corrected. The machine works out line lengths, where to begin a new page, and even corrects simple spelling mistakes. The text is stored in memory chips controlled by 2 microprocessors. They rearrange the text by shunting it from one memory block to another.
All sorts of new ideas sprouting forth. And we do want to be able to tap them off, to be able to give somebody with a good, if you like, lateral thinking idea of applying a microprocessor in an entirely new sort of way, give him the opportunity of really building on that, exploiting it, producing a world-beating product from it, marketing that product, and reaping the rewards from it.
The example of industry creation that everyone quotes is the EMI body scanner. An X-ray camera rotates around the patient's body, taking various pictures from different angles. All the pictures are fed into a computer, which combines them into a single view, as if you would see a section cut cleanly across the body, a view in which you can see the backbone, the muscles, and everything.
What do EMI have that the others don't have? They have software, in the widest sense. They have a piece of applied mathematics that enables them to process the information, do this on computers, and to create the image. That is what they have. The heart of it is software, and that immediately, in a short time, leads to an industry creation.
An idea that didn't exist 5 years ago has now sold £200 million worth of equipment. Is our future, then, the creation of more industries like this? One can hope so, but so far there are no other examples to point to. What will happen, then, to the men in today's jobs? Can we all live on the wealth of automatic factories and the earnings of an elite band of 60,000 software engineers? It's time to think about the future.